Okay, at this point, we have talked about spherical lenses that are cut from a glass sphere, and light passing through them gets focused to a single point, and in a lens cross, it looks something like this. Power cross, rather, it looks something like this. Okay, if this were a +3 diopter lens. We've also talked about cylindrical lenses that are cut from glass cylinders, and these lenses focus light not to a single point, but to a line. And with a power cross, they look like something like this. This is a cylindrical lens. Well, that brings us to a third type of lens that we're going to talk about today, and it's called a toric lens. Okay, so we have spherical lenses, we have cylindrical lenses, and we have toric. If a spherical lens is cut from a glass sphere and a cylindrical lens is cut from a glass cylinder, what is a toric lens cut from? And the answer is a glass torus. And a torus is like a bagel shape or a donut shape. And toric lenses, we'll get into this part later, what toric lenses focus light to. But what a toric lens looks like on a power cross is something like this, where you have two different numbers. In that way, they're like a cylindrical lens because the numbers are too different, but neither number is 0. Neither number is plano. And this is what a toric lens is. So this would be the next stage in our progression. Okay? So with a toric lens, the reason it's interesting it's cut from a glass torus is, think of a torus. Think of a donut that we've cut in half. Okay? And we have two different, completely independent radii of curvature. We have this one here, the red one, and we have this one here. I'm sorry, the blue one. And this one here, the red one. So if you think of it, if the bagel that we cut it from looks like this is the red one. It's like the size of the bagel, and this is the blue one, which is like the height of the bagel. And they're independent of one another. What do I mean by that? Well, what I mean is we can have a bagel that looks like this. Same diameter, but much less meat on it, right? So this bagel may look like this, where the red R is the same as the top one. Let's call it A. So the red line in A is the same as the red line in B, but the blue line in A is much, much, much smaller in A than it is in B. Or we can have this type of situation where we have the same height bagel, but it's much, much, much smaller. So this bagel might look like this, okay? And here we have the red is much smaller from A to C, but the blue from A to C is the same. So we can change A and we can change the two different radii of curvature. We can change the separately. So we can change the height of the bagel, or we can change the length of the bagel, separate from one another. Okay. So what we end up with when we cut a lens from a bagel is it kind of looks partly like a spherical lens and partly like a cylindrical lens. And what we end up with is, if we were to look at the lens from the front, okay, we would end up with one curvature which is kind of steeper and one curvature which is flatter. Okay? Now, if you compare that to a spherical lens, both of these curvatures are the same. And if we compare it to a cylindrical lens, we have one that's steeper and we have one that's flatter, but it's so flat it's actually a straight line, and that's the axis line. So now what we have is we have two different curvatures, which are, again, totally independent of one another. So if we plot that out now on an optical power cross, and let's look at that example we had before where we said it's +3 across this meridian. This is power now, not axis, and +5 across this meridian. Just like we talked about before, what is the power halfway in between? It is halfway in between. And what is the power halfway in between here? It's halfway in between. And if we were to average the power everywhere on this lens, what would the average power be? It would be +4. And the other thing that we see here is nowhere on this power cross do we have a power that's less than +3 or greater than +5. +5 is the highest number we get. +3 is the lowest number we get. Okay, so nowhere on here do you see +2, nowhere on here do you see +6. So by writing that we have a +3 there and a +5 there, it's a way to show us the highest and the lowest numbers we have on this whole power cross. So it's a nice shorthand way to do it because we know everything else is between +3 and +5. Okay, we're going to spend the next few talks going into toric lenses more, basically how to build toric systems using spherical lenses and cylindrical lenses, and hopefully as we go farther along, things will become clearer, because I know at this point it's probably not all that clear.